Good morning, afternoon, or evening. Today is day 24, last topic in probability. Independent probabilities. Okay, probabilities that don't have any overlapping. Okay, so that when the probability of independent probabilities, a little bit easier than the probability of non-mutually exclusive events. So it's very similar to non-mutually exclusive and exclusive event type stuff. Okay, so we're going to be looking at that today. As soon as our blackboard opens up, we'll outline kind of what we're going to look at. Okay, conditional probability. We did some work on page 250 the last day, I think, if I remember correctly, as well. So let me just make sure that I did that. So I'm going to pause this for a second. Okay, so we did do that, no problem there. So let's kind of go through. Hopefully, if you had some questions on that, we'll see. There we go. Let's get. If we had some questions on page 250, 350, we'll see. Hopefully, I responded to them and you guys did okay. What we're going to look at then today is the last section, independent probabilities. So this is day 24 of unit 3, probability, and this is our last topic, independent probabilities. Okay. This means that the probability when you have two or more events, the probability of doesn't affect the other probability of the other event. So basically, each event's probability is independent of the other. Does not, okay, so that's what it means, does not affect the other event probability. Okay, so flipping a coin, we talked about that earlier, flipping a coin, rolling a dice, that what you get on the dice is not affected by what you get on the coin. Okay, so there is a formula for this. For the mutually exclusive events, we have to do some subtraction. For the independent events, okay, it's this one. Let's get to a small marker here. Okay, so if we probability of A and B occurring equals the probability of A times the probability of B for independent events. Okay, an example of this would be the flipping of the coin example and rolling the die. Let's do that one again. Okay, so what is the probability of rolling 3 on a 6-sided die and flipping heads a coin, 2-sided coin, obviously. Okay, not 2 heads on it or anything like that, a regular type coin. Okay, 6-sided die. There we go. Okay, so basically it's the probability of the dice, rolling a 3 on the dice, times the probability of getting a heads on the coin. So the probability of rolling a 3 on the dice, there's only one 3, so it's 1 out of 6. And the probability of getting heads in a coin, there's 1 heads out of 2 sides. So then it would be 1 out of 12. So that's your probability of getting a 3 and heads. Okay, if we have the notation, 1 out of 12. Okay, then that's pretty easy to do for those types of events. Okay, now where it gets a little bit confusing is when they start throwing in complementary events and using different wording and things like that. So let's kind of bring up some examples where we're going to be using complementary events. Not will be a word that happens a lot, and then there'll be the or, and then you have to decide whether it's an independent formula or whether it's the dependent formula. So this is typically and is the word that you typically see for just multiplying the two. Probability for rolling this and this. Okay, if you see the word or, then you might have some overlap. You might not, but you might. So you have to be careful, and that's when you get into that non-mutually exclusive or independent events and dependent events. Okay. Okay, so let's go back here and look at a couple more examples in this area. So let me get my examples page down over here, and then we'll do an example that deals with complementary events as well. Okay, so this is pretty simple, but let's go into a complementary event. So let's do that on this page. So this example that we're going to do is two independent events and complements. A complement meaning not the not thing, right? Okay, so let's say we have the probability of waking up early is, let's say, 40% on a weekday. The probability of going to bed early is 22% on a weekday. Okay. Okay, assume these are independent probabilities. Okay, and find, okay, let's do a couple here. Let's do the probability there we go, of waking up early and going to bed late. Okay, so there's the and, right? Okay, and let's do probability of waking up late and going to bed late. Okay. So we got a couple of questions. So first step that you always do is you should define your variables and also define and kind of no-tip them. Now, when we're talking about complementary events, we use that prime symbol. Okay, so if I'm going to say probability of waking up early, okay, that's going to be 0.40, 40%. I'm going to write them as decimals. Okay, the probability of not waking up early, okay, probability of not waking up early, this is waking late, okay, we don't need a new variable for it because it's a complement of this. So that would be 1 minus 0.40, or 100% minus 40% gives us 60%, or 0.60 as we write it as a decimal. Okay, if we're going to say sleeping early, so let's say probability of waking up early, waking up late. Okay, and then the other one is going to bed. So we'll call it B. So this is sleeping early. Okay, going to bed early is only 22%. Okay, the probability of staying up late or not going to bed early. That's 1 minus 0.22, so equals 0.78. Okay, so there's our probabilities. And now we can just use the independent formula. Okay, so question A is asking us the probability of waking up early and going to bed late. So probability of waking up early and going to bed late. Going to bed late is this one. Okay, because they're independent, we just multiply the probabilities. So 0.40 times 0.78. Okay, again, we could probably do a tree diagram in this one as well if we wanted to. So 0.4 times 0.78, that's going to give us 0.312. And this equals the probability of waking up early and going to bed late. Okay, just like the formula right there. We're just multiplying those together. Okay, so B will be very similar. Okay, they're asking us for the probability of waking up late. Probability of waking up late. So waking up late is right here. Not waking or waking late. And going to bed early. Going to bed early, that's sleeping early is B. Okay, so that's what, and they're independent events, so we have to take and multiply them out. So this is going to equal the probability of W prime times the probability of B prime. Or not B prime, sorry, just B. There's no prime in there. So W prime here, waking up late, is 60%. Times waking or going to bed early is 22%. Multiply those two numbers together. Oh, sorry. Sleeping early. Going to bed late. What am I doing? This is a prime. It should be a prime. This is early, so I got it backwards. Do the correct one here. Right? It says going to bed late, going to bed early. Not going to bed early. I forgot to read the not, right? Not going to bed early is going to bed late. So that should be 78 there. Sorry, guys. You have to be more careful when you read, and so do I. So 0.78 times 0.6, that's 0.468. if you like it as a percent. So that's the answer to B. So that's basically how those work. Now, let's throw in an OR with the same question, okay? So that we don't use this formula, we have to go back to the OR formula. Okay, so what if, because they'll do that in this section, okay? So let's throw an OR question in here, okay? So what is the probability of waking up early or going to bed early? Call it C. Okay, so you got to remember the OR formula. For mutually exclusive and non-mutually exclusive events. Okay. Okay, so OR is this. Get that so it's right near the top. Okay, so if we remember the OR formula, okay, so the probability of waking up early or going to bed early. Okay. Waking up early or going to bed early, sleeping early. These two. Or is the union of the two, okay? So for doing that, we have to remember the OR formula is probability of W plus the probability of B minus any overlap there might be. This is where W intersect B. So that's what we have to use. So the first step that you think of is you have to figure out to yourself, well, how do I know if these are independent events? Because we're assuming that. Step one, calculate probability of W and B occurring at the same time, right? Waking up and going to bed early, not or, but that's the thing you have to calculate first. According to the independent theory, that's PW times PB. So that's what we have to figure out first. So PW, waking up early, was 40%. Okay, and we have to multiply that by going to bed early was 22%. Okay, so we got to take a calculator out for that one. 0.4 times 0.22. And you get 0.88. So there is a little bit of overlap. So they're non-mutually exclusive events, even though they're independent of each other, because there is some overlap. Okay. And now we can apply the formula in step two. Apply the OR formula. Okay, so the OR formula we wrote on top here. Okay, so I'm going to write it again just so we W or B. Okay, so the probability of W, so that was 40%, plus the probability of B, that was 22%, minus the probability that they both occur, So the overlap. And that's going to give us a total. So that's okay, so if we do that subtraction there, you get 0.532 or 53.2%. So you can have independent events that have some overlap, right? Even though one probability doesn't affect the other. It's not like you're drawing a card like conditional probability, and then you draw another card, and there was one missing from the deck, right? So you have to be careful of that. So that's an example of the or. So don't get messed up. When you're doing the and, you're just multiplying the probabilities. When you're doing the or, you have to remember to use this formula to be careful of the overlap. Okay, so let's see what we're doing, how we're doing on time here. Okay, that's about 20 minutes. So let's go ahead and do like a typical question that you'll see in this is warranty type problem. Okay, so let's do one like that. And then we'll probably stop there. And what I'll do then is probably save tomorrow. I'll save the work period type stuff for tomorrow. We'll do a warranty type problem here. They take a little bit longer to think about. So in this third example, we're going to be looking at an independent Okay, there's quite often they give you warranty problems. Okay, so let's set one up here. Let's say in a 3-year period, so that's where your warranty period. Okay, so you got a 3-year warranty. A switch on a computer fails 7% of the time. Video card on the computer will fail 15% of the time. Okay, we'll just do 2 events. Okay, assuming independent events. Find the probability that and we'll do 3 of them. Let's go. Both the switch and video card fail. And I'll highlight the important word. And that's an and question. Let's throw in a switch fails, but not the video card. Okay. And the last one, let's throw an or in there. The switch fails. Or video card fail. Let's throw one more in. What the heck? Nothing fails. Neither fail. That would be possible. Okay, so the first thing we should do is we should write our probabilities out in step one. So step one, define your variables. So switch, fail. Let's say that's an S. Video card fail. Let's say that's a V. Okay. Okay, so then what we'll want to do is we'll want to write out the probabilities and their complements. Okay, so number two, write out the probabilities and their complements. Okay, so probability that the switch is going to fail. Okay, the probability that the switch in the computer fails is 7%. So 0.07 if we write it as a decimal. Probability that it doesn't fail is 100% minus 7, which would be 93%, which would be 0.93. So that's 1 minus 0.07. Okay, we do the same thing for the video card. Probability that the video card fails is 15%. So that the probability that the video card does not fail is going to be 1 minus 15, which is 85% or 0.85. 1 minus 0.15. Is that? So once we've done that, and then now what we do is we use the independent and formula, event and formula, or the or formula, depending on which one we're using. So now we're going to solve each. And, okay, so we want the probability of the switch and the probability of the video card. Okay, there's no or in there, so we don't have to do any subtracting. So it's 0.07 times 0.15. So this would give us the probability of the switch and the video card failing. Switch and the video card failing. So our answer there is going to be 0.07 times 0.15. So we get 0.0105, which if we do it as a percent is 1.05% if we move the decimal over 2. Okay, so there's your probability that both are going to fail before the warranty runs out, the 3-year warranty. Okay, now we'll do B. The switch fails, but not the video card. The switch fails, and the video card does not fail. Okay, the switch fails and the video card does not fail. So that's the probability of the switch times the probability that the video card does not fail. So prime in there. Okay, so video card prime is this one over here. So this would be switch fails and the video card does not fail. Okay, you got to take our calculator out, 0.85 times 0.07. And we're left with 0.0595. Or, if you want percent, 5.95%. Okay. Now, the last one, or second last one, pardon me, is an OR question. So we have to use the OR formula. Switch or the video card fail. Okay, so in this one, we want the switch or the video card fail. SUV. Weird. Okay, so we know we got to use the formula. Okay, so we know that that's the probability of the switch plus the probability of the video card failing minus the overlap that could happen. Oops, why am I putting two P's in there? Sorry, guys. Probability that both happens. Probability that the switch fails and the video card fails. Okay, so the switch and the video card failing we got from A. If you didn't do part A, you'd have to do it before you could solve that. So this is going to be, in our case, 0.07 plus 0.15 minus 0. What do we have there? 0.105. Okay, take our calculator out and crunch those up. 0.07 plus 0.15 minus 0.0105. You get 0.2095. So then if we write that as a percentage, that's 20.95%. So the probability that the switch or the video card, either of them, will fail is that 20.95. Okay, D, the probability that they both fail, probability that they neither fail. Okay, they both keep working. So D would be the probability that the switch does not fail and the video card does not fail. So both complements. So the switch complement was, what was it, 93? Switch was 93 and the video card was 85. Forgot the prime there. Okay, there's no overlap in there because there's no OR. Okay, and we just multiply the two together. So 93% times 85%. So that's going to give us 79.05%, or 0.7905. Okay, so that's 79.05%. Okay, so that kind of covers all the areas in probability. The last one being these independent, and an OR type questions. Okay, so let's see where we are for time here. Okay, so that's about 35 minutes. So I'm going to assign some practice for tomorrow. So I'll leave tomorrow as a practice day. But I will, if you want to get started today, I will put them up today, and I'll put so you can get started early if you feel so inclined. Let me just pause here because I've got to read. I don't have it on my other side here, so I will dig up some for you to practice. Okay, so we're near the end here. So some of these questions will use some of the other concepts like drawing tree diagrams, using combinations, using permutations. Okay, so I'm going to give you a couple, and I'll give you a bit of a hint for each one. So this is on page 360. Okay, so number one is just determining whether it's an independent or dependent event based on the situation. So remember, independent events, one probability doesn't affect the other. Okay, and you can do number four, which talks about number one, For each situation in question one, determine the probability that both events will occur. Okay, if they're not independent, you have to do it in a different little way. Okay, so that's 4. 5, suppose that they give you some results. Are they independent or not independent? Okay, remember that if it follows that formula, this or that formula, then they'll be independent. If it doesn't equal it, then they're not independent. Okay, the tree diagram for number 6. You can do tree diagrams. Just do a tree diagram for the first child, and then the second event would be the second child, whether it's a boy or a girl. Okay, skip 7. That one uses combinations, so we'll skip that one. 8, 9, and that should be good, I think. Okay, so you can start those, and I'll give you, I'll let you work on those next period and think about them a little bit as well. So that's what we'll do next period as well. So we'll see you tomorrow.